So let's just do the question number 20. For me this is a take 2 because I forgot to actually turn off one of the screen. So let's see, it's this one, right? So it's the same problem as the question number 19. You're supposed to calculate the N2 plus O2 becoming 2NO, and then you're supposed to get the delta G of formations. But what happens if your thermodynamic table is somehow blocked, that you don't get the delta G? So the entire column of this guy is completely blocked, so you don't get none of these guys. You only have the informations here and the informations there. Then what's going to happen? What can you do about it? And the answer is that you can actually get the same numbers. So let's just try to get the informations. I already got the informations for you guys, but let me just try to see. The enthalpy of formations of the nitrogen is that one, and then the entropies of the nitrogen is this one. Remember that I don't have access to this guy right here. And other things that I need to tell you is that enthalpy of formation is usually in kilojoule. The free energies, the Gibbs free energies, also kilojoule, but note this: the entropy values is usually given in joule per Kelvin, joule per Kelvin mole. Okay, that's not kilojoule, that's joule. Okay, so 191 is actually related to the joule here. Alright, so I got all of those guys. So the information I got for this is these values. Remember that I don't have this one right here just because the table may be blocked in the exam, but I do actually get the delta H values, delta H of formations for nitrogen, oxygen, and then the NO, and then the delta S values for nitrogen is that delta S values for the O2 is given that, and then entropy value of NO is actually given by that. So by plugging in these type of things, then you can actually get the same information. So let me just try to erase all of these guys, just because that this is a take 2, right? So the delta H of the reaction, delta H of formation, sorry, delta H of formation. I'm gonna, did I actually turn off? No, I didn't. Great, I caught that, same mistake. Just making sure, yep, it's on. So this is 0, and that's 0, and then that one right there is a 90.25. Oops. And 2 is same, just because it's a 2NO, right? And then the delta S, so which is gonna be 191.61, and then 205.15, and then I have 2 here, and then I have 210.76. Okay, so delta G of delta H of reaction is given by the delta H of reaction is equal to product, always product minus reactant, right? So product is 2, so 2 times that, because you have 2 NO, right, as a product. The reactant is all 0. Note that this is actually kilojoule per mole. Okay, and then the delta S of reaction is actually equal to same stuff, the product, which I have two of these guys, minus that plus this, and that one right there is actually joule per Kelvin per mole. Okay, good. Then the delta G of reaction, delta G of reaction is actually equal to the delta H of reaction minus T delta S of reaction. So I have to actually multiply temperature, right? But temperature is 298. Well, it's a room temperature 25 degrees Celsius, right? But you can't use it just Celsius. You have to convert it to the Kelvin. So it's 25 plus 273.15. You get 298. That's it. That's my T. So equal T delta S. So I get that, but that's in joule, right? Remember that this thing is joule, right? And everything else is a kilojoule, so I should probably divide this value by 1000. Okay, so now that I have kilojoule per mole for the T delta S, T delta S reaction. Okay, so what I have, the delta G of reaction, delta G of reaction is delta H of reaction minus T delta S. So delta G of reaction minus T delta S. So I get that. Notice that this value right here is pretty much the same as the delta G of reaction. So you don't really have to have the delta G values. As long as you get the delta H and the delta S, then you can actually get the same informations out of that. So that's the question number 20.